Hey everybody, this is the notes for 5.3. This is a really important section. Particularly the b to the negative n is one of the most important things you'll do in this course. It's something that will serve you basically from here forward. If you get it here, it's really important to pick up. So let's get started. All right, so the definition of b to the 0 is always that b to the 0, anything raised to the 0 power is 1. The only thing not captured in this definition is 0 to the 0 power because b can't be 0, so 0 to the 0 power is undefined. But anything else, 10 to the 0 power, 100 to the 0 power, negative 100 to the 0 power, 5,362 to the 0 power, all of them, no matter what, equal 1, period, every time. So look at this one. 4 to the 0 power, 1. Negative 4 to the 0 power, 1. Be careful on the next one. Think about the parentheses, right? Would be 4 to the 0 power times the negative makes negative 1. Z to the 0 power, still 1, okay? Negative 4 times z to the 0 power is z to the 0 power is 1. Negative 4 times 1 is negative 4. And then 4z all to the 0 power, that's going to be 1. This is the trick, this one. So if n is an integer and b is a non-zero number, so like a regular real number, then the definition of b to the power of negative n is 1 over b to the power of n, or 1 over b to the n. Negative in an exponent does not mean it's a negative number. Negative in an exponent says flip. Okay, it means take the reciprocal, flip it into the bottom part of the fraction. Once you do the flip, the negative goes away. You did that action. Okay, it's like putting a sticker on something or taking a sticker off. Once you take it off, it's gone. You use the negative. The negative in an exponent does not say negative, it says flip. So let's see what that really looks like. So if I have c to the power of negative 3, what that means is I'm going to flip c over from where it is now. Technically, it's this right now. But I'm going to flip it into the denominator. And when I do that, the negative goes away because I used it to do that action. 5 to the power of negative 1 just becomes 1 over 5 to the 1, which is just 1 over 5. Okay? Here, I'm going to flip first in negative 3 to the negative 4th. I'm going to do the flip and then I'll apply the exponent. Okay, so I'm going to have 1 over negative 3. The flip used the negative, so it's gone. And then 1 over negative 3 to the 4th. Well, what is negative 3? What's 3 to the 4th? Oops, it would help if I did that right on my calculator. Let's just make it sure it is 81. Negative 3 to the 4th power is 81. Okay, p to the negative 4th is just really 1 over p to the 4th. The negative goes away. Luna, nope. 1 or 3 to the negative 3 is another flip. 1 over 3, the negative goes away to the 3rd. And then I'm going to finish that. It's 1 over 27, it's 3 to the 3rd. Okay, and then I have negative 5 to the negative 2. The negative 2 says flip. Do the flip first. See it as 2 pieces. Becomes 1 to the negative 5 squared, which is the same as 1 over 25. That's it. This is the trick to this, though. You have to see that negative as flip. So when things get a little more complicated and it's already in a fraction, what changes is how we flip, right? If the number's already in the denominator, then it flips to the numerator. So 1/6 to the negative 2, okay? becomes 6 over 1, technically, squared. That's the same as 36. All right. Negative 3 over 5 to the negative 3, I flip the fraction, becomes 5 over negative 3 to the power of 3. And then I have to distribute that exponent. So 5 to the third on top, negative 3 to the third on the bottom. That's going to get me 125 over negative 27. Y, 1 over y to the negative 5 is just going to flip y to the negative 5 into the numerator. It's going to be y to the positive 5. All right, you see where this is going. You try the next couple, pause the video. D 1/3 to the negative 1 is just going to flip into a positive 3. No value, this number didn't change its sign. The negative exponent is never about a sign. Okay, negative 2/5 to the power of negative 2 just becomes negative 5 over 2 squared. And that's going to be negative squared is positive. 5 squared is 25. Oops, that doesn't look anywhere in here like a 25. 25 over 4. All right, and then the last one is just going to turn into w to the 7th. All right, let's see how these work. So this one is 5x to the negative 3. The whole thing is being raised to the power of negative 3, so the whole thing gets flipped. And then I have to give that cubed to everybody. So 1 over 5 cubed is 125. X cubed is just x cubed. The next one is 5x to the negative 3. It's just the x to the negative 3, so that's the only one I'm going to change. I only flip the x. So the 5, technically right now, is 5 over 1. It stays there. And the x flips into the denominator to the third. Then the negative drops away. Okay? This last one is the same exact thing. The negative 3 is not being applied to the negative 5. So it just stays where it is. That's all that happens there. All right, so when we simplify expressions with exponents, a completely simplified expression will never have negative exponents in it. Always answers have to be simplified down to having positive exponents. So they always have to get flipped to where they belong. Okay, so let's try a first. A to the third is just what it is. C or b to the negative 2, this says flip, so b squared is going to go in the denominator. And then c to the negative 5 is already in the denominator and needs to move up to the numerator, so it's become c to the 5th. Now it's done because all the exponents are positive. For b, I'm going to do the same thing. So I have x squared, that stays where it is. X to the negative 7th goes down to the bottom, x to the 7th. And x to the third stays in the bottom. There's no negative exponent. Now I need to simplify the x's. So I have x squared on top, and I have x to the 10th on the bottom, so we added those. And then I can subtract. So really the way I'm going to think about it is I have 2 x's on the top and I have 10 on the bottom. I think I made 10. 1, 2, 3, 4, 6, 10. And so I'm going to cancel those. What's left is 1 over x to the 8th in the denominator, right? Because that's where the most x's are left. All right, and then let's do this last one. Z squared stays where it is. W to the negative 4th goes to the numerator. W to the negative 4th becomes just w to the 4th. W to the 4th, the positive one, stays in the denominator, and z to the 8th moves up. So now I just have to simplify. That's a z instead of a t. So w to the 4th cancel. because there's w to the 4th on the top and the bottom. And I'm left with z to the 10th. That's all. All right, you try each of these. These ones are for you. I am not going to go all the way through them. You are going to try them. I will put the answer. If you get stuck, come on into the chat or the discussion. Why do I say that every time? So A should be z to the 8th over y to the 4th, x to the 6th. And if you have x to the 6th, y to the 4th, same difference, doesn't matter, okay? B should simplify down to 1 over x to the 9th. And C should simplify to p cubed z squared. All right, so now let's try something a little different. So when we have this negative exponent on the outside that applies to everybody, what it tells us to do is do a full flip first, okay? So I'm going to do this in stages. So to start with, I'm going to flip everything. So I'm going to do this 1 over negative 4, a, b, to the negative 2, all of that cubed, okay? Now I'm going to distribute that cube to everybody. So I have 1 over negative 4 cubed will be whatever 4 cubed is, and then negative 64, negative 64, a to the 3rd, b to the negative 2 times 3 is negative 6. Now I can't leave that like that because I can't have a negative exponent in my answer. So b to the 6th has to come to the top. It's going to be b to the 6th positive because I flipped it over negative 64, a to the 3rd. If you're stuck somewhere along the way, go take another look. Watch the video again, okay? We're going to do the same process for the second one. First, we're going to flip the whole thing. Okay, so that's 5p squared q on top over 2p to the negative 4 q to the 3rd, all of that squared. Okay, and then I'm going to distribute that 2 everywhere. When I do that, what I get is 5 squared on top is 25. P squared is p to the 4th, q squared. On the bottom, 2 squared is 4. P to the negative 4th squared is p to the negative 8th. And q to the 3rd squared is q to the 6th. And now I'm just going to simplify. Sorry, Puppy and I are having a conversation while we work. So I need to move this p to the negative 8th to the top. I'm going to move my screen down a little bit. So I still have 25, p to the 4th, and now also p to the 8th, that moved to the top, q squared. On the bottom, I have 4 q to the 6th. And then I'm just going to combine things that need to get combined. The p's need to get combined and the q's. So I have 25, p to the 12th, 4 and 8 is 12. And then I do 2 q's on top, 4 q's on the bottom, or sorry, 6 q's on the bottom, leaves 4 on the bottom. Q to the 4th, 4. This is a really systematic process. The more systematically you approach it, the easier it's going to be for you. So just take it one step at a time. Your brain at some point is going to tell you you're overwhelmed, but you're not. You can do this. You just have to go step by step by step. Okay. All right. These ones I want you to try. Follow the same steps we followed a minute ago. And let me know. I'm going to put the answers here. Come on into the discussion if you're stuck. So for A, it should be x to the 4th, 25y to the 6th on the bottom. And for B, it should be 4. Nope, it shouldn't. I lied. I'm not looking at the final answer. It should be 16 x to the 8th over 9y squared. Okay, see what you can do. If you're stuck, please ask for help. All right, and then there's one final thing here. These are kind of funky looking. but they're not as bad as you think. So simplify the expression, write the answers with positive exponents only. Take it one step at a time. So 2 to the negative 1 is just flipping the 2 in the denominator. It just means half. Plus 3 to the negative 1 is just 1/3. And 5 to the 0 is same as 1. So now I just have to add that stuff together. Well, to do that, I need a common denominator. Common denominator for 2 and 3 would be 6. So half is the same as 3/6. 1/3 is the same as 2/6. And 1 is the same as 6/6, right? That's a whole. So if I add all that together, I get 11/6. I'm done. All this is. Okay? Do the same thing in B. 2 to the negative 1 is just half. 4 to the negative 2 is 1/4 squared. 1/4 squared is 1/16. And then 3 to the 0 is just 1. So now instead of eighths, or sixths in this case, I'm going to use 16ths. So half is the same as 8/16. And then I have 1 more 16. And then I have 16/16. So 8 and 1 and 16 is 25/16. All right. So from here, move on to the next thing in the module, if it's the next set of notes, or into the ALEKS work, whatever makes sense for you. And I will see you in the next video.